Hello everyone, and welcome back to my channel. Thank you for joining us today. We're excited to explore an often overlooked yet vital component of our body's circulatory system, blood vessels. Blood vessels are intricate networks that transport blood throughout our body, playing a crucial role in maintaining overall health. There are three main types of blood vessels: arteries, veins, and capillaries. 1. Arteries carry oxygen-rich blood away from the heart to the tissues, supplying them with the necessary oxygen and nutrients. 2. Veins return oxygen-poor blood back to the heart, ensuring the continuous flow of blood and allowing for the removal of waste products. 3. Capillaries, the smallest blood vessels, are where the exchange of gases, nutrients, and waste occurs between blood and tissues. Together, these vessels form a complex system that not only delivers essential substances to various organs and tissues but also plays an important role in regulating blood pressure and flow. Understanding the structure and function of blood vessels is fundamental to grasping how our bodies maintain homeostasis and respond to various physiological demands. Let's dive deeper into this fascinating topic. Blood vessels are tubular structures in the body that transport blood to and from the heart and throughout the body. They are a crucial part of the circulatory system, which provides oxygen, nutrients, and hormones to tissues and removes waste products like carbon dioxide. There are three main types of blood vessels. The types of blood vessels in the human circulatory system are: 1. Arteries. Function: carry oxygen-rich blood away from the heart to the body. Characteristics: thick, elastic walls to withstand high pressure from the heart's pumping. Examples: aorta, coronary arteries. 2. Arterioles. Function: smaller branches of arteries that lead to capillaries. Characteristics: help regulate blood flow and pressure by constricting or dilating. 3. Capillaries. Function: facilitate the exchange of oxygen, nutrients, and waste between blood and tissues. Characteristics: extremely thin walls, 1 cell thick, allowing for easy diffusion. 4. Venules. Function: small vessels that collect blood from capillaries and lead to veins. Characteristics: thin walls as they carry low-pressure blood. 5. Veins. Function: carry oxygen-depleted blood back to the heart. Characteristics: thin walls with valves to prevent backflow of blood. Examples: superior vena cava, inferior vena cava. Each type of blood vessel plays a specific role in maintaining the flow of blood and overall circulatory health. Here's a more detailed specification of the types of blood vessels and why each is necessary. 1. Arteries. Function: carry oxygen-rich blood from the heart to various parts of the body. Characteristics: thick, muscular walls to withstand high pressure from the heart. Elasticity allows them to maintain blood flow during the relaxation phase of the heart. Examples: aorta, the largest artery, directly connected to the heart. Pulmonary arteries carry oxygen-poor blood from the heart to the lungs for oxygenation. Why necessary? They ensure oxygen and nutrients are delivered quickly to tissues, critical for energy and survival. 2. Arterioles. Function: smaller branches of arteries that regulate blood flow into capillaries. Characteristics: smooth muscle in their walls allows them to constrict or dilate, controlling blood pressure and flow. Why necessary? They control the distribution of blood to different tissues based on need, ensuring efficient oxygen and nutrient delivery. 3. Capillaries. Function: exchange of gases, nutrients, and waste products between blood and tissues. Characteristics: walls are only 1 cell thick, allowing easy diffusion of substances. Dense networks in tissues, particularly in areas with high metabolic demand, e.g., muscles, brain. Why necessary? They facilitate vital exchanges that keep cells alive and functioning properly. 4. Venules. Function: collect deoxygenated blood from capillaries and channel it into veins. Characteristics: thin walls, often involved in immune responses by allowing white blood cells to exit into tissues. Why necessary? They provide a pathway for blood to return to the heart and remove waste products from tissues. 5. Veins. Function: carry oxygen-poor blood back to the heart. Characteristics: thinner walls than arteries since blood pressure is lower. Contain valves to prevent backflow of blood. Examples: superior vena cava drains blood from the upper body. Inferior vena cava drains blood from the lower body. Why necessary? They ensure the continuous circulation of blood, completing the cycle and maintaining homeostasis. Why is this necessary? The specialization of blood vessels ensures 1. Efficient oxygen and nutrient delivery. Arteries and arterioles rapidly transport oxygenated blood to meet tissue demands. 2. Precise regulation. Arterioles adjust blood flow based on need, e.g., during exercise or rest. 3. Vital exchange. Capillaries ensure every cell receives what it needs and removes waste. 4. Waste removal. Venules and veins return deoxygenated blood and waste for processing and excretion. 5. Circulatory balance. Maintains blood pressure, fluid distribution, and overall bodily functions. Without this system's structure and function, tissues would not receive oxygen or nutrients, waste would accumulate, and life would not be sustainable. Here's a more detailed specification of the types of blood vessels and why each is necessary. 1. Arteries. Function: carry oxygen-rich blood from the heart to various parts of the body. Characteristics: thick, muscular walls to withstand high pressure from the heart. Elasticity allows them to maintain blood flow during the relaxation phase of the heart. Examples: aorta, the largest artery, directly connected to the heart. Pulmonary arteries carry oxygen-poor blood from the heart to the lungs for oxygenation. Why necessary? They ensure oxygen and nutrients are delivered quickly to tissues, critical for energy and survival. 2. Arterioles. Function: smaller branches of arteries that regulate blood flow into capillaries. Characteristics: smooth muscle in their walls allows them to constrict or dilate, controlling blood pressure and flow. Why necessary? They control the distribution of blood to different tissues based on need, ensuring efficient oxygen and nutrient delivery. 3. Capillaries. Function: exchange of gases, nutrients, and waste products between blood and tissues. Characteristics: walls are only one cell thick, allowing easy diffusion of substances. Dense networks in tissues, particularly in areas with high metabolic demand, e.g., muscles, brain. Why necessary? They facilitate vital exchanges that keep cells alive and functioning properly. 4. Venules. Function: collect deoxygenated blood from capillaries and channel it into veins. Characteristics: thin walls, often involved in immune responses by allowing white blood cells to exit into tissues. Why necessary? They provide a pathway for blood to return to the heart and remove waste products from tissues. 5. Veins. Function: carry oxygen-poor blood back to the heart. Characteristics: thinner walls than arteries since blood pressure is lower. Contain valves to prevent backflow of blood. Examples: superior vena cava drains blood from the upper body. Inferior vena cava drains blood from the lower body. Why necessary? They ensure the continuous circulation of blood, completing the cycle and maintaining homeostasis. Why is this necessary? The specialization of blood vessels ensures 1. Efficient oxygen and nutrient delivery. Arteries and arterioles rapidly transport oxygenated blood to meet tissue demands. 2. Precise regulation. Arterioles adjust blood flow based on need, e.g., during exercise or rest. 3. Vital exchange. Capillaries ensure every cell receives what it needs and removes waste. 4. Waste removal. Venules and veins return deoxygenated blood and waste for processing and excretion. 5. Circulatory balance. Maintains blood pressure, fluid distribution, and overall bodily functions. Without this system's structure and function, tissues would not receive oxygen or nutrients, waste would accumulate, and life would not be sustainable. Yes, several living organisms do not have blood vessels. These organisms rely on other methods for transporting nutrients, gases, and waste products. Here are examples and the mechanisms they use instead. 1. Single-celled organisms. Examples: amoebas, paramecia. Why they don't need blood vessels? They are small and have a high surface area to volume ratio. Nutrients and gases diffuse directly through their cell membranes. 2. Simple multicellular organisms. Examples: sponges, phylum Porifera, jellyfish, phylum Cnidaria, flatworms, phylum Platyhelminths. Mechanisms. Sponges use a water flow system where water carrying oxygen and nutrients enters through pores and exits through a central cavity. Jellyfish have a gastrovascular cavity for nutrient and gas exchange. Flatworms rely on diffusion due to their flattened bodies, which allow cells to be close to the surface. 3. Invertebrates with open circulatory systems. Examples: insects, mollusks, like clams and snails. Why they lack blood vessels? They have an open circulatory system where blood, hemolymph, is pumped into open spaces, sinuses, around their organs. Hemolymph bathes tissues directly to transport nutrients and gases. 4. Plants. Why they don't have blood vessels? Instead of a circulatory system, they have vascular tissues like xylem, for water and minerals, and phloem, for nutrients. These are not equivalent to blood vessels but serve a similar purpose for nutrient and water transport. Why these organisms don't need blood vessels? Size and simplicity. Small or simple organisms can rely on diffusion for transport since their cells are close to the environment. Low energy demands. Many of these organisms have lower metabolic rates and don't need fast, efficient transport systems. Alternative systems. They use systems like water flow, sponges, gastrovascular cavities, jellyfish, or open circulation, insects, to meet their needs. Blood vessels are a necessity in larger, more complex organisms, e.g., humans, birds, that require efficient, high-speed transport of substances due to their size and metabolic demands. Blood vessels are crucial for the human body because they form an essential part of the circulatory system, which sustains life by ensuring that all cells receive the nutrients and oxygen they need while removing waste products. Here's why they are so important. 1. Transport of oxygen and nutrients. Blood vessels, particularly arteries and capillaries, transport oxygen-rich blood and essential nutrients to every part of the body. This supply supports cellular respiration, which provides energy for bodily functions. 2. Removal of waste products. Veins and capillaries carry carbon dioxide and metabolic waste from tissues to organs like the lungs, kidneys, and liver for elimination. This prevents the accumulation of toxins that could harm the body. 3. Regulation of blood pressure and flow. Blood vessels help maintain proper blood pressure to ensure efficient circulation. Arterioles can constrict or dilate to regulate blood flow based on the body's needs, e.g., during exercise or rest. 4. Immune system support. Blood vessels transport white blood cells and antibodies to sites of infection or injury, playing a critical role in immune defense. Venules allow white blood cells to exit the bloodstream and reach affected tissues. 5. Hormone distribution. Blood vessels carry hormones from endocrine glands to target organs, regulating vital processes like growth, metabolism, and reproduction. 6. Body temperature regulation. Blood vessels near the skin can dilate, widen, to release heat, or constrict, narrow, to conserve heat, maintaining an optimal body temperature. 7. Support for organ function. Every organ relies on blood vessels for its operation. For instance, the brain needs a constant supply of oxygen-rich blood to function properly. The heart itself depends on coronary arteries to stay nourished and pump effectively. 8. Healing and repair. Blood vessels deliver clotting factors and nutrients to wounds, aiding tissue repair and recovery. What happens without proper blood vessel function? Blocked arteries can lead to heart attacks or strokes. Weak or damaged vessels, e.g., aneurysms, can rupture, causing life-threatening situations. Poor circulation can lead to tissue damage, ulcers, or even loss of limbs. Conclusion: blood vessels are vital for maintaining life and health. They act as the body's transportation network, ensuring every organ and tissue gets what it needs to function and thrive. Without healthy blood vessels, the body cannot sustain itself. If the human body did not have blood vessels, it would be nearly impossible for it to survive because blood vessels play an essential role in transporting oxygen, nutrients, and waste products throughout the body. Without them, the body would need an entirely different system to achieve these functions. However, here's a speculative look at how the body might survive under such conditions. Alternative mechanisms for survival. 1. Direct diffusion. In very small or simple organisms, like flatworms, oxygen and nutrients diffuse directly through their surface to reach cells. For humans, this approach is unfeasible because the body is too large and complex for diffusion to supply all cells efficiently. Cells deep within the body would not receive enough oxygen or nutrients. 2. Open circulatory system. Some animals, like insects, have an open circulatory system where a fluid called hemolymph bathes organs directly in an open cavity. For humans, this would require major anatomical changes to distribute oxygen and nutrients evenly, a heart-like structure to pump hemolymph around the body. This system would be much less efficient, especially for an organism as large as a human. 3. Specialized transport tissues. Instead of blood vessels, the body could evolve specialized transport tissues, similar to xylem and phloem in plants, to carry nutrients and oxygen. Challenges. These tissues would need to adapt to the high metabolic demand of human organs, such as the brain and muscles. 4. Multiple hearts or pumps. Without blood vessels, the body might rely on multiple heart-like pumps placed throughout the body to circulate blood or another fluid. Each pump would serve a specific region, but coordinating them would be highly complex. Challenges to human survival without blood vessels. 1. Inefficient transport. Blood vessels ensure that oxygen and nutrients are delivered quickly and efficiently. Without them, cells would starve or suffocate. 2. Waste removal. Blood vessels transport waste like carbon dioxide to organs like the lungs and kidneys for elimination. Without this system, toxins would build up, leading to cell death. 3. Size and complexity. Humans are large and complex organisms with trillions of cells. Without blood vessels, it would be nearly impossible to support all these cells evenly. 4. Temperature regulation. Blood vessels help regulate body temperature. Without them, the body would struggle to maintain a stable internal environment. In reality, humans cannot survive without blood vessels. The circulatory system is perfectly adapted to our size, complexity, and energy needs. Without it, life as we know it would not be possible. For a human-like organism to exist without blood vessels, it would require a completely different physiology, likely resembling much simpler organisms. In the video we covered several key points about blood vessels, including their structure and function, the different types of blood vessels, arteries, veins, and capillaries, and the integral role they play in the circulatory system. We also discussed how blood vessels can be affected by various health conditions and the importance of maintaining vascular health. We'd love to hear your personal experiences or insights related to blood vessels. Feel free to share your thoughts in the comments below. If you enjoyed this content, please like, share, and subscribe to our channel for more informative videos. Thank you for watching.